William, hopefully your favorite videographer from Two Hats Publishing. I welcome you to another Two Hats special of community events. Let's look in and see what's really happening.
All right, ladies and gentlemen, boys and girls, welcome to the Professor Newton Science Show. My name is Professor Newton, and this is my show. Isn't that? That's the way it goes. Ladies and gentlemen, I love science. I think science is fun. I think science is exciting. You can do all sorts of great things with science. And I'm going to show you some experiments this afternoon, some of which you can do at home if you get mom and dad's permission. So we're going to start off with a little something right now. Some people ask me, they'll say, Professor Newton, what is a scientist? Well, I'm going to ask you some questions. Think about it for just a second. Exploring. Does anybody here like to explore? Raise your hand. That is awesome. Look at that. That's great. I'll ask you another question. Anybody here like to invent things, even if it's in your own mind? Do you like to do inventions? That's great. Do you like to do inventions? Like to do inventions? Cool. All right. How about sorting things? This thing goes here. This thing goes there. You like to sort things out? How about experiments? Anybody like to do experiments? Yeah, me too. How about discovering new things? You like to discover new things? Yes! All right. Do you like to test things? Does this work? Does that work? Do you like to test things out? Do you like to test things out? You do? Good. All right. How about, I dropped my pointer. How about classifying things? This is big, this is small, this is tall, this is, all right. Or collecting things. Anybody like to collect stuff? Rocks, or flowers, or leaves, or, oh, that's cool. Well, if you can say yes to any one of those things, you are on your way to becoming a scientist. We're going to have some fun with science today. I'm going to start off with a little something. Looks like a magic trick, but it's really science. I have here my little ping pong ball. And what I'm going to do is I'm going to throw this ping pong ball up into the air, and I'm going to catch it in a very unusual way. No, ladies, I'm not going to catch it in my hand. That's too easy. No, guys, I'm not going to catch it in my mouth because that's just nasty. What I'm going to do is I'm going to throw this ball up into the air, and I'm going to catch it on my nose. Now, if I am successful, I would like everybody in the audience to break out into thunderous applause, because I know if this ball hits the floor, you're all going to laugh your little heads off, right? All right, so let's go over the deal. I'm going to throw the ball up in the air. If I catch it on my nose, you're all going to... Got to hear it, got to hear it. All righty, good. And if I mess up and the ball hits the floor, you're all going to... Yeah, you're all going to laugh. All right, here we go. Excuse me 1 minute. I'm giving the ball instructions, excuse me. All right. I need absolute silence. Let me see if I can do it, and... Hey! Come on, I want to hear it! Woo, 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 woo! Very good. Let me explain what's going on here. Plastic was discovered by a chemist in 1863, purely by accident. He was working inside of his lab, he messed up, and he discovered plastic. And what was an accident in 1863 has turned into a multi-billion-dollar industry. And what I did before the show is I took a little bit of acid-free rubber cement and I coated that on the outside of the ball. And then I also put a thin coat of rubber cement on the end of my nose. And the molecules in the rubber cement are so attracted to each other that when they come together, they hold on for dear life, just like this. It's the miracle of chemistry. Now, we played a little bit about, or talked a little bit about molecules. I want to do a little bit more about molecules. I'll tell you something. When you have one molecule, that's called a monomer, because mono means one. And when you have a whole bunch of molecules together, they're called polymers, because you have, poly means many, so you have a whole bunch of molecules. And so we're going to kind of pretend that each one of these beads is a molecule, because when you have a whole bunch of molecules together as a polymer, when they're all strung together, they're called long string polymers. And what's really cool about them is you can have hundreds or thousands or millions of them. So let's just pretend we have our microscope on right now, and we're going to take a look at this long string polymer. These are all these molecules all connected together in this one big long string, and that's so cool. You can do a lot with long string polymers. I have a question for everybody. Raise your hand if you have a little brother or sister at home. Anybody got a little brother or sister? All right, very cool. Then you probably know what this is. Everybody know what this is? Yeah, we know what it is. And you know what? I'm going to show you a little bit of science that you can do at home using one of these, a clean one preferably, and mom or dad's permission. Now the very first thing you want to do is you want to cut this open, and when you cut it open, you're going to discover inside there's a whole bunch of this cotton stuff. So you want to get yourself a sandwich bag and take the cotton out, take all of the innards out of that diaper, put it inside just like this. And you're going to find a little white powder in there too. You kind of scoop it all up, put it into the bag just like this, and start to shake the bag. Shake, 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 just like this. And when you're all done, you open up the bag, take out all the cotton, and you're going to discover something pretty cool. In the very bottom, you're going to have a white powder, and this is called sodium polyacrylate. Sodium polyacrylate. And it does something pretty cool. But I'm not going to tell you what it does. I'm going to show you what it does. But in order to do that, I need to have a volunteer. Would you like to help me? Why don't you come on up here? Be very careful coming up these steps. There you go. Good job. Stand right there if you would, please. Turn right around, look at everybody. What's your name? Connor. Connor. Hey, Connor. I'm going to ask you a silly question today. Did you take your shower today? Yeah. Okay, good. And I know it's kind of a weird question, but the reason I'm asking you that is that you might kind of be taking another shower in just a minute. But don't worry about it. Here's what I want you to do, Connor. I want you to take and hold this cup just like this. Give me the other hand, Connor. We're going to put that hand right there. And we're going to have you hold it right over your head just like that. Now, at the moment, Connor has an empty cup. I'm going to fill that cup up with a little bit of water. In fact, I think I'm going to do about, I got to put on my glasses because Professor Newton's getting pretty old. I'm going to put about 120 milliliters. That's almost 4 ounces of water in there. So let's see. La-da-dee, la-da-da. All right, hang in there, Connor. Oh, you're not even trying to put it over your head. But don't you worry. Connor, kind of put that over your head. Just like that, buddy. All right. Connor has a cup of water over his head, and I have a very sharp pencil. Let's see if we can have a little bit of fun with that. Connor, I'm going to just kind of push this pencil in just like this. Woo! You feel anything on your head yet, Connor? No? Good. Now just put one pencil in there. Should we do more than one pencil, ladies and gentlemen? I can't hear you. Yes, all right, good. Just so happens I have a spare. All righty, Connor, stay right there, buddy. Go put another pencil in there. Wah! Feel any water yet, Connor? No. I don't know. I don't think 2 is enough. Should we do one more? Should we do 3 pencils? Should we do All right, all right. I love seeing those faces. All right, Connor, I'm going to do one more pencil here, buddy. Why don't we put one here, just like this. La-da-dee, la-la-la. All right. Connor, buddy, you feel anything? No, all right. Well, I'm not going to leave the pencils in there. So this might get ugly. Just stay right there, Connor. I'm going to pull this pencil out here like this. I'm going to pull this pencil out like this. And last but not least, I'm going to take that pencil out just like that. You see anything, buddy? No, and I'll show you why. Remember, I did a little bit of diaper magic, all right? Let me have that cup right there. Hold your hand out, Connor. See, what I did, ladies and gentlemen, is I put some sodium polyacrylate in there. Let me show you what happens. Plop. Look at that. All that powder that we had, that little bit of powder from the diaper, turned into this big, slobby, nasty-looking jelly thing, and that is sodium polyacrylate. What it does is it absorbs 500 times its weight in water. What's it feel like to you, Connor?
It feels kind of like snow, but kind of like slime.
Kind of like snow and kind of like slime. Good combination. Toss it in there, Connor. Hey, you know what, buddy? Want to help me with one more thing? All right, cool. Well, I want to do one more experiment with water. I like things that involve water and goo and mess. The interesting thing about long string polymers, you got to think of them kind of like spaghetti. Got to think of them like cooked spaghetti, long strings. And what happens is they're very flexible. I'm going to show you how flexible they are. Now I have here a sandwich bag. It's made out of a polymer. And this one happens to be called low density polyethylene. And we make a lot of things out of low density polyethylene. Sandwich bags being one of them. Kind of hold that open, Connor. Just kind of hold it just like that, buddy. Just like that. And I got some more water. So let's have a little bit more fun with the water. La-da-dee, la-da-da, la-da-dee. La, la. Should I put more in? Yeah, let's put it all the way in. Yeah. See, I can tell you love that, Connor. Alrighty, now let's zip it shut. I'm gonna zip it shut. I'm gonna hold the bag this time, Connor, and I'm gonna let you have a little bit of fun. I want you to take this pencil, Connor, and I want you to push it through the bag. Kind of turn the pencil like that as you're doing it. Don't push it all the way through. Just kind of push it through the other side, okay? So let's kind of push it in. Yep. Keep going, keep going, keep going, keep going, keep going, keep going. Good job. All right. That's good. And we'll push it through a little bit more. All right. Does it look like it's leaking? Nah, it's not leaking. Should we do another pencil, ladies and gentlemen? All right. Good, good, good. Connor, got another pencil for you, buddy. Go for it. Kind of put one there. Just kind of put there. And you see how we did it before. Good, good, good. Kind of push it through. Kind of push it through. Good. All right. And one more. Should we do one more, ladies and gentlemen? All right. Good job. Connor, do one more for me, bud. All right. Put it right there. Go ahead. Yep. That's pretty good. All right, now Connor, take a look at that. Do you see any leaks going on in there? No. All right, here's what I want you to do. Kind of hold the bag just like that, because I'm going to talk to everybody real quick. I want to talk a little bit about something called the scientific method. The scientific method, there's 4 points to it. We have guess, do, observe, and answer. Guess, do, observe, and answer. Now, I talked a little bit about long string polymers. I talked about how they were like flexible little pieces of spaghetti. And when you push them aside, their molecules will seal up around an object. Like in this case, our pencils. So I'm going to ask everybody a question. You can see that the molecules have sealed up around the pencil. So, do you think when we pull these pencils out, do you think because the molecules are flexible, they're going to seal up and hold that bag, you're going to seal up and not let the bag leak? Or do you think that those molecules are going to stay where they are and leak? So I'll ask the question. If you think it's, when they take the pencils out, if you think it's going to leak, or if you think it's not going to leak, raise your hand. If you think it's not going to leak, okay, you don't think it's going to leak, okay. If I pull the pencils out, do you think it's going to leak? Raise your hands. Ooh, about half. Doesn't it look about half? All right. What do you think? You think it's going to leak or you think it's going to seal up?
I think it might leak.
You think it might leak? Well, that's very nice. You're writing right on the fence. You think it might. Is it going to leak or is it not going to leak?
I believe there's a 50% chance of each.
Well, you think you're... Thank you, Connor. He says there's a 50% chance of each. Go for it. Give me a yes or a no. Is it going to leak or not leak?
Maybe it will. I guess it will leak.
You think it'll leak. All right. Well, let's find out, shall we? Go ahead and pull a pencil out. All right? Uh-oh, look at that. Ah, pull out another pencil, Connor, and pull out one more, buddy. All right. I'd say right offhand, that's leaking like a sieve, isn't it? I'll tell you why. Because the molecules, even though they pushed aside and they sealed up around the pencil, when you pull them out, because they've been pushed aside, they never go back in place, so it would never, ever not leak. Connor, you did a great job. Let's give Connor a great big round of applause. You can have a seat, Connor. Go on down. Thank you, buddy. Careful going down. All right. Well, let me see. In science, we study the states of matter. And there's a bunch of states of matter, but there's 3 that I'm thinking of that really kind of, they're the very first 3 that we think of. Can somebody give me one of the states of matter? One of the states of matter. I bet your Connor would know. Would you give me one? Liquid's one of them. You bet. Give me another one. Somebody else. Give me another one. Gas. All right. What's the last one? Solids, liquids, and gas. All right, we got 3 different states of matter. We're going to have a little bit of fun with the states of matter, and we're also going to have a little bit of fun with something called acids and bases. Whenever you mix an acid with a base, you're going to get a change. And we're going to have a little bit of fun not only getting a change, but we're going to end up with the 3 states of matter as well. I have a base right here. So what I'm going to do is I got my balloon, and I have a measuring cup, and I think we're going to put about 30 milligrams of base inside this balloon. So I'm going to put 30 milligrams. That's 15 right there. And do another 15 right there. All right. I have 30 milligrams of base. And I think we're going to do about 600 milliliters of acid. This should be really cool, I hope. It's a little unpredictable. So let's see what we got going on here. All right. Yeah, I hope it doesn't blow up. All right. I got my acid, I got my base, and I have a liquid, I have a solid, and I hopefully going to come up with something else. So let's kind of put this, let's put this right over the top just like that. La-da-dee, la-da-da. And here we go. Whoa, whoa, oh, yeah, buddy. Come on, you can do it. Come on, woohoo. Last show it almost blew up. All right, well, we had a liquid, we had a solid. What's in there, everybody? Gas, that's right. Now, what gas do you think it is? Anybody got a guess as to what gas is in there? What gas is in there? What do you think, Connor?
Helium.
Not helium, nope. Helium's something, that's a natural gas. Somebody, anybody else? What do you think it is? What do you think it is? Carbon dioxide. Give them a round of applause. That's right. Woohoo! Yeah, because what do you think my acid was? Anybody? Vinegar, thank you. So what do you think the base was? Baking soda. Acid, base, whenever you mix an acid with a base, you're going to get a change. In this case, it was CO2. And CO2, of course, is a carbon. It's a carbon molecule, two oxygen atoms. That's cool. All righty, one more quick thing I'm going to show you. And I need 5 people, actually, for this. So let me see. I'm going to take you. Yes, you. And I'll take you. You want to do it? Why don't you come up? You come up, too? And yeah, okay, you come on. All right. Sorry, guys. All right, let me see. We got the lone lady in the middle. I'm going to put the lady in the middle. Woohoo, right there. All righty. And I'm going to put you over here between her and him. Tell you what, you stand there. You stand there. You stand there. All right. This is the really hard part. You hold his hand. You hold her hand. You hold his hand. You hold his hand. All right. Now, when you go into a dark room, what's the very first thing you do? You turn on a light. That's right. You flip on a switch. And that's what we're going to do here. I need you to hold this side right here, just like this. Kind of hold on. Just hold on to that. Come on over here and hold on to that. And now what we've got going on here is we have completed a circuit. There's a flow of electrons going from this person to this person to this person to this person to this person all the way into this, and it's just continuing to cycle just like that. Now, everybody keep holding on. You let go of his hand. Let go of his hand. Okay, now, touch his cheek. Take your finger off, put your finger on. Go ahead. Take your finger off, touch his nose. Touch his nose. Take your finger off. Now, touch his ear. Touch his ear. What's happening is we're completing the circuit. Everybody is a conductor because of the fluids and the minerals in their body. Now, I want you to do one other thing. Touch his hair. Now, it's not working. Somebody want to give me an idea why it's not working? Give it to me.
He's not touching his skin.
What's that?
He's not touching his skin.
Yeah, because he's touching his hair, and what is it? It's not a, what is the word? Not a conductor. That's right. Excellent job. Ladies and gentlemen, let's thank all of our volunteers for helping us. Thank you. Well, we talked a little bit about molecules. We talked a little bit about chemistry, acids, bases. We talked about liquid, solids, gas, and we did a little something on electricity. Ladies and gentlemen, that's my show today. You've been a wonderful audience. Give yourselves a great big round of applause. I'm Professor Newton. You have a great day today at the 4th of July. Thanks for coming by. By the way, we got a show coming up right over here, a magic show coming up at 6 o'clock. So go on over to the stage over there and enjoy the magic show.
Magic show.
Oh, that's where the professor lives.
This is William, hopefully your favorite videographer from Two Hats Publishing. I hope you enjoyed this video. If you like it, please leave comments below, or like, follow, or subscribe to us and get notices of all our videos. We love it, even when you call.